All right, so this is the thinking review questions for insulin resistance and dyslipidemia. Make sure that before you check your answers that you attempt to complete the thinking review questions and then watch the video and look at the handout to make sure that your answers are correct. All right, so let's go ahead and let's talk about, let's go through these. So the first one is decrease in hepatic lipase in the liver. What would happen to the triglycerides, small dense LDL, HDL, and coronary heart disease risk? Well, in this particular case, if you have a decrease in hepatic lipase, it's going to cause an increase in triglyceride, a decrease in small dense LDL, an increase in HDL, and a decrease in coronary heart disease. The question is why would that be the case? In this particular case, if you have dyslipidemia, VLDL triglyceride would still increase as free fatty acids enter the liver. And the liver would still use the free fatty acids to make new VLDL triglycerides. So since hepatic lipase is downstream, it would not be affecting the amount of free fatty acids that would be entering the liver and being used to make new triglycerides. So you'd have an increased amount of triglycerides that are being formed. However, with hepatic lipase, it would affect the small dense LDL because of the fact that you would have less hepatic lipase available to change the LDL into a small dense LDL. At the same time, you'd have a decrease in hepatic lipase would cause an increase in HDL because you have less hepatic lipase to break apart the HDL from the ApoA1. Step number 6. Also, taken together with a reduction in small dense LDL and an increase in HDL, that would cause a decrease in the coronary heart disease. What about if you decrease CETP? And you remember CETP is responsible for exchanging triglycerides and cholesterol with VLDL and HDL and VLDL and LDL. So in this particular case, VLDL triglyceride would still increase as free fatty acids enter the liver. And the liver, again, would use those fatty acids to make triglycerides. So CETP would not affect the amount of free fatty acids being changed into triglycerides in the liver, so that would actually increase the amount of triglycerides. However, CETP would cause a reduction in small dense LDL because you have a less of an exchange between LDL and VLDL, with LDL decreasing the amount of cholesterol to VLDL and VLDL giving less triglycerides to LDL. And therefore, there would be less LDL that would be triglyceride rich that would return to the liver to be made into a small dense LDL. At the same time, you would have a decrease in the amount of exchange between VLDL and HDL, and therefore you have a reduction in the amount of HDL that would be rich in triglyceride that would return to the liver. And therefore, you would have an increased amount of HDLs in the circulation. Taken together, you would have healthy HDLs, a decrease in small dense LDLs, and therefore that would cause a reduction in coronary heart disease. What about increased exercise? Well, increased exercise is going to cause a reduction in adipose tissue insulin resistance, and therefore reduce the amount of free fatty acids making its way to the liver. Therefore, the liver would have a reduced amount of fatty acids that it could use to make triglycerides. So you'd have a decrease in triglycerides, VLDL triglycerides. Exercise would reduce the effects of CETP, thus reducing the exchange between VLDL and HDL, and VLDL and LDL. So therefore, more HDLs would remain in the blood, and less LDLs would be made into small dense LDLs. Taken together, you would have a reduction in the coronary heart disease. What about high-fat diet? Well, a high-fat diet is going to cause the opposite effect of exercise. High-fat diet is going to cause an increased adipose tissue insulin resistance, cause an increased amount of free fatty acids going to the liver to be made into VLDL triglycerides. At the same time, high-fat diet would increase the amount of CETP that would be activated, so causing an increase in the amount of HDLs that would be triglyceride rich, that would then be taken back to the liver to be reduced or broken apart by hepatic lipase. At the same time, high-fat diet would cause an increase in CETP in the exchange between VLDL and LDL, with LDL becoming triglyceride rich, and then be in effect causing the LDL to be changed into small dense LDL. So essentially you'd have an increase in steps number 4 and step number 10. As a result, with less HDL, more small dense LDL, you'd have an increase in coronary heart disease risk. And finally, a high simple sugar diet. A high simple sugar diet would cause more VLDLs to be made by, VLDL triglycerides to be made by the liver, and they also would cause VLDLs triglycerides to remain in the blood longer. Sugar would also upregulate CETP, so step number 4 and 10 would be upregulated, causing a reduction in HDLs, but an increase in small, dense LDLs. As a result, with more VLDL triglycerides, less HDL, more small, dense LDL, that would cause an increase in the coronary heart disease risk. All right, if you didn't get it the first time, try again. Make sure you understand how the rationale as to how the results were the way they were. And again, continue to practice on Blackboard and looking over the pathways.